Hello, Professor. I am Yeshwanthi Vaddadi. So, now casting of macroeconomic variables using payments. This is our project, and we are from Section 3, Group 4. So, jumping into the project, our table of content consists of about our team, project overview, project status, project phase, challenges, and solutions. Coming to my team, as I already mentioned, I am Yeshwanthi. I am team lead, come data analyst. Next is Aniket Walse. He is developer come data analyst, and Rohit Varma is data analyst come developer. So we three had equal portions in this project in developing, analyzing, and collecting the data which is required for this project. And project overview. Let's talk about my client, Payments Canada. In the name itself, we can say payments. So this organization is a financial organization which operates Canada's payments and their settlement systems. Basically, in one word, we can say this organization is responsible for transaction between financial institutions, individuals, whether they are processing safely and following the guidelines and standards. So basically, they are responsible for secure payments. Next, client requirements. I'm going to state the client requirements as of now as the two main indicators we considered as GDP and CPI. So to know, we are going to build a machine learning model to predict those values by collecting data of macroeconomic variables, including employment rate, unemployment rate, wholesale rate, retail rate. And this model is used to evaluate and to provide more precise and meaningful predictions. Project objective. As I already mentioned, we are just building a model, machine learning model, just to see the growth of GDP and performance of CPI by using these variables. And project status. As of now, we are on track as the client's requirement is to collect data using APIs from different sources like Stats Canada, Fred, and different platforms. Uh, we collected successfully whatever clients provided, and the project is going good. There are no delays in the project. And project phase. As I'm talking about project phase comprises of requirement, design, development, and testing and release are yet to be done, and we will be doing that further. So first coming to resources, as I already mentioned, data collection part and whatever the resources we should get from client is 100%, and data collected of listed macroeconomic variables are 100%. And the sources we used, basically Stats Canada and Fred, these are the two main sources where we got each and every data and their APIs as well. And as I'm talking about resources, these are few variables listed by client. In that, we mainly choose unemployment, CPI, employment, wholesale trade, retail trade. So as of now, we are just going to predict uh, these CPI and GDP by using these variables: employment rate, unemployment rate, wholesale trade, retail trade. How these factors or these variables are affecting the growth or non-growth of GDP, the performance of CPI. So based on this, we are going to build a model. Model building and the design phase, whatever in the design phase, like merging the data, everything will be in the design phase. Basically, what we did, we collected from different sources. We didn't download it, but we checked in which resource or which platform the data was accurate. Based on that, we collected data and we merged data finally. So next, Aniket is going to explain about design phase.
Thank you, Yashwanti, for your presentation. Now I'll be taking over the presentation where I'll be discussing the design phase of the project where we have done importing of the libraries used, then collection of data, how we have collected data from different sources, then we have applied multiple merging techniques to gather that whole source of data, like from different sources under one data frame. Then we have got rid of null values using techniques such as drop NA. We have had some null values in our data, so we have taken care of that as well. Then comes the distribution part of the data, like what is the distribution of our data, what is the maximum range of the data, minimum range of the data, what is the quartile ranges like mean, median, mode, and all those values of distribution data. And the last comes with the EDA, where I'll be talking about the EDA part which we have performed. So to show now, I'll be discussing the PPT first. I will go through each and every slide, and then later on I'll explain the technicalities by showing the code which we have done. So to start with, first comes, as said, like the part of importing libraries. So we have imported several libraries. So these are just the libraries which we have used to do all the data cleaning and data related things, not the development. So the development part is later on, the model building. So those are not the, so now I'll be not showing those libraries. I'll be just showing the libraries which we need to get the data, final data. So these are the libraries which we have used. Then comes the merging data part, where we have merged the data based on different data frames. So you can see here we have GDP, CPI, then employment based data, unemployment based data, employment rate, unemployment rate, then wholesale trade, retail trade. All this data has been combined in a single data frame called as data final, where we have used the merging technique to merge the data based on year, month column, and then the final columns which we get in the data is this, all those columns which we have shown earlier. So after this comes the cleaning part. As we have taken the data directly from Stats Canada using API, so most of the data which we have got was in a form of clean format. There was not much to do in terms of cleaning, but still there we found some of the null records. So in order to get rid of those null records, we have used the drop any functionality, a basic functionality, and to apply those on data in place true we have used, and this is basically the final shape. So as you can see, we have got rid of 5 records which were null in our data. Then comes our, as I said, the distribution part of the data. So this is the basic screenshot which does not show the whole distribution, but yeah, the basic distribution, some part of the distribution of the data, where you can see like the CPI, the count of the values for each and every feature. The count of the value is 312. That means we have 312 records, and here you can see the mean, median, and maximum range of the record. Then comes the part of the EDA, where we have shown the data EDA for GDP, CPI, and and the correlation part. So this is the interactive part of the EDA. So I'll be shifting to the code now, where you can see the techniques used. Like here we have used all those libraries. Then comes the part of APIs, where we have used the API. So this is the API which is called as vector, where the period represents the number of months. Then this is the GDP analysis part. Here we have done the analysis part, which shows the the range of GDP growth rate for each and every year. So this is the monthly data distribution for GDP, and here is the section based development of the each and every code which we have done, where we can see different categories analysis. Then comes the part of merging data. So this is the part of merging data as discussed earlier in the PPT. Then comes the part of exploratory data analysis, where we can see exploratory data analysis year wise, each and every year wise. And then comes the part of model building, which will be explained by Rohit. Thank you.
Well, hello all. This is Rohit Varma. Thank you very much, Aniket, for taking us till here. So, well, moving on forward with the development and the modeling process. So, initially we have done splitting the data into test data and train data. The train data basically being 80% of the data which we have, and the test data being 20% of the data. That's how generally we split the data, right? So next, moving forward with building the models. So we have used all these linear regression, reg regression, elastic net regression, decision trees, random forests, and XGBoost regressors in order to build the models. So these are the libraries which we can see here are being used. So just let me walk you through what each exactly means in a one-liners. So linear regression, basically it's an approach of modeling the relationship between a dependent variable and one or more independent variables. And then the lasso regression being the it performs the L1 regularization, which can lead us to feature selection. So similarly, the ridge regression being the ridge CV stands for ridge regression, and it is cross-validated selection. It performs the L2 regularization, which can help in finding out the multi-collinearity between the data. And the decision tree regressor, it uses a binary tree structure to make predictions by splitting the data based on featured thresholds. And then the random forest regressor, it's basically it combines multiple decision trees to make predictions, so it basically reduces overfitting and improves our prediction accuracy. And then the XGBoost, which is very much known as extreme gradient boosting, and it's a gradient boosting framework. It is known for its efficiency and performance in various machine learning tasks. So these are all the necessary libraries which we have used for building the models. So, well, moving on, this is how we have split the data, and we can see the shape being 311 by 6 as the X shape. And so we have used all the variables as explained by Aniket and Yashwanthi. So these are the variables which we have considered and how it's affecting the CPI. And similarly, how all the other variables have been affecting the GDP. So we have split it like this. We can see 80% training data and 20% being the test data. And then we can see here the data modeling, the decision trees, random forests, the regressor, XGBoost regressor, the linear regression model, rich regression model, and the elastic net regression model. And well, before moving on to the visualizations, let me just show you through the code and how it does look. So well, here it's clearly seen. Here are the models which we have used. So the linear regression based prediction for GDP. So here we can actually see the predictions are very much on par with the actual data. So if we go to the visualizations part, so linear regression based prediction for GDP, and over the years we can it's almost the same. And similarly, if we see the GDP actual and predicted plot, this also moves accordingly. So similarly for linear regression based prediction for CPI, again, that was for GDP. CPI also has almost the same amount of equality between the predictions and the actual data. It's almost the same. So CPI actual versus predicted plot. And then the feature importance, the random forest regressor. From the random forest regressor, we have got the feature importance being, well, we can here clearly see that the retail trade, wholesale trade, and the CPI being the most important features. So we can see that. And before moving there, let me just show you through the code. If we see here, yeah, well, we can clearly see that the model's accuracy is almost 99%. That is very much true because we have 312 rows of data being each and every month for almost like from 1997 to 2023, but we're going to add more data, so it's going to actually change later on where we have to develop it more. So this being the coding part of it. And now moving on to the challenges and solutions. The data collection, the collection of APIs, finding what specific APIs are supposed to be used, the macro variables which are given by the client. We have selected a handful of variables from the list which was given, and the data range, like choosing the right duration of data. And it was critical since data was gathered from multiple sources like GDP, CPI from a source, and other variables from other different sources. So it was a bit challenging for us in order to like get into the same plot. So then the budget of the project, well, the development hasn't been added here because we haven't completed the project yet, but it's gonna add up though. Well, now, yeah. So this is the graph which was generated from the SharePoint, according to the overall budget and the sum of actual budget. So, well, coming to the upcoming challenges, we still have cryptocurrencies, which was given by the client. Like they just gave us the symbols and their corresponding categories. So we have to actually, work on them and add up to this project. And hope the need is satisfied according to the project, and we are very much delighted and pleased to work till here, and we are willing to move forward with a lot to do. So, well, that's all. Thank you very much.